Hey people, what's good? Mount Let the Hellfire. Welcome back for another video. I hope everybody's doing great, and if you're new here, welcome to the channel. On this channel, we explore topics such as signals intelligence, communications, electronic warfare as it's pertinent to the prepared citizen. I also have some other specialist content within my catalog, including Knight's Armament, SR-25 M110 gunsmithing, SR-15 gunsmithing, suppressor testing, scope reviews, and otherwise, and we'll continue to widen the scope of the channel. So I invite you to stick around, find out about today's topic. And as you can tell from the title and the thumbnail of the video, we're going to be doing a beginner tutorial on using SDR software. SDR, of course, meaning software-defined radio. Some examples I have out on the table in front of you. In this video, we're going to be using CubicSDR, which is technically end of life, but it is featured enough to do basic communications intelligence tasks and collections with communications intelligence, meaning intel gleaned from, well, voice, data, communications, human to human, right? Whereas electronic intelligence is more intel gleaned about the sources of emissions, which you could technically do with an SDR software, a GUI-based one like CubicSDR, but not really. I'm going to be recording this on a Windows 10 laptop running whatever the latest version of Windows 10 is as of June 2025. And Windows 10 is going to be end of life soon, but fuck Windows 11. So to actually follow along, I'm going to be using an RTL-SDR. I'll be using a V3, but you could use a V4 as well. Either work, or you could use something a little bit more higher powered. This is a Blade RF 2.0 AX9, I believe. I also have a Hack RF1 that is compatible. Pretty much any SDR hardware that is compatible with SOPI SDR drivers will work. Now, if you are going to use a RTL-SDR, you're going to want to make sure that you have a SMA female thread with a pin like this one, right? So that's what right looks like, is that it threads on and it has the pin inside of it because, well, there's no pin here. This is wrong. This is an SMA male. Now, if you had an adapter, you'd be fine, but it doesn't matter. As long as you have an antenna that's properly tuned for whatever frequencies you want to listen to. Just to make it easier for everybody, we're going to actually be monitoring some VHF channels for the National Weather Service, but then also show you how to use radio reference database to look up frequencies around your area. So maybe do some homework, legwork, but I like these Nagoya VHF UHFs, and pretty much any ham radio antenna will do. So enough yapping, let's get over to the video and I'll walk you through all of this. So we are here finally in CubicSDR. This is version 0.2.8, which is the latest stable as of the end of June 2025. And I'm on a Windows 10 laptop running the latest release version of Windows for, well, June 2025, though that shouldn't matter too much. The screen I have up here is CubicSDR, the actual user interface here on the left, and on the right is a screen that'll preload all SOPI SDR compatible devices by default. Now, I chose to do this on a Windows laptop for the reason that you actually might not see this. So this generic RTL-2832 uniform OEM, Oscar Echo Mike, is the RTL-SDR. But if you don't see all of these options here on the right, or if you don't see this option at all, what you're going to need to do is navigate over to zadig.akio.ie, so Zulu Alpha Delta India Golf dot Alpha Kilo Echo Oscar dot India Echo. Or you could just type in Zadig into Google or whatever your preferred browser is, and it should pull it up. And you'll go ahead and download the latest version, which is 2.9. And when you have it downloaded, it'll appear like this. And what you should do is, if you see something here, usually it'll say input device 0 or generic USB input 0, something like that with your RTL-SDR installed. And I already installed the driver for it, so you're not going to see this drop up. You'll pick one or both, and then ensure that you have WinUSB selected, and then you would just install driver. But you see there's no option there because, well, I don't have anything selected. It'll take a couple minutes, and then if you did have a interface slot 1 and 0, whichever one you did, do the other one, but if you only see one, that's fine. Install it, close Zadig out, close CubicSDR out completely, maybe unplug and replug your RTL-SDR, and if needed, restart your computer just to go through all the possible things. Now, what will happen if you have a partial install or a weird install that no matter what frequency you set, no matter what antenna you have, you'll just hear a bunch of static and noise floor no matter what you do. So with all that out of the way, CubicSDR, you install it from CubicSDR.com, and then you would just go to the CubicSDR downloads and then pull whatever version. I believe they also have a GitHub. For whatever reason, it just only has 0.2.4 here. So you would go to the GitHub releases, and then you would see the latest releases over here in the code, right? So that's where I got mine from. And I guess I must have a beta version or something, because this is only saying 0.2.7. Now, CubicSDR is quite old, obviously, since this hasn't been updated in a while, but it's one of the easier ones to orient you to because it's pretty simple. It doesn't have any built-in support for like DSD or whatnot. It's as bare bones of a SDR, software-defined radio, software as you could get. But anyway, we're going to go and pick our RTL-SDR, and then we'll go ahead and hit start. And then I'll make this full screen, and hopefully you could see that. So I already have this set to a center frequency. I was messing with this a little bit before. I'll reset this, but just to orient you. So starting in the top left here, you have your various built-in modulations. Frequency modulation, narrowband frequency modulation, lower sideband LSB, upper sideband USB, just regular IQ file capture as well, and a couple others that you could select depending on the SDR software. When you pick narrowband frequency modulation, NBFM or narrowband, whatever you want to call it, it'll preload the bandwidth of 12.5 kilohertz, which is standard spacing. You could increase or decrease that here. You could set it as high as like 17, 18, but 12.5 is usually the sweet spot. And then your modem settings would appear over here if you had an active window, and this is where the waterfall will show for whatever active channel that you're trying to listen to do your communications intelligence tasking on the collection side of the house. Then you set your center frequency, and your center frequency is, well, what it would center up as, and your complete bandwidth that you have able to monitor greatly depends on your RTL-SDR or whatever SDR you're using. I'm using a V3 right now, not a V4. So I have just about 2 megahertz or 2.2 megahertz. It'll set that automatically. Now I have this color code set up over here in color scheme, which is set to look like SDR sharp. So anything in this darker blue is the noise floor, and then obviously this bright red orange is the higher power, right? So maybe it's because you're close to where the broadcast is at, or maybe it's just using a higher wattage, whatever it is. And then this is the bottom of the noise floor, negative 60.2 dB. On going back to the left side over here, you could see that I do quite a bit of scans as it is. Just recently, while I was getting set up for the recording, making sure that I had everything good to go. So you could set up recents, you could set up various bookmarks, and then you would have your active channels as well. Now, if you hit spacebar, that'll pull up the shortcut for the center frequency, and I'll set it to 162.550. And this is so you could do it anywhere in the United States, because 162.550 megahertz is the National Weather Service, essentially. And then now that I'm over here and I have my 12.5 kilohertz spacing, I could actually go and click in at this peak over here, and it'll move it to an active channel. Let me just make sure that I'm actually centered up here.
Reported with a temperature of 73. At Washington, D.C., drizzle was falling with a temperature of 71.
Now I'll throw that gain down a little bit so it doesn't overpower me when I'm actually talking. But you could drag and drop. You see where it's probably hard to see on mobile, but that toggle, I have the 4-way arrow, and you can move this around, and you hear I have static. Now you could also click and drag to increase the bandwidth. And you see over here, now I'm up to 19.1 kilohertz. And then now I'm at 9.1 kilohertz, right? So that's how you do the different settings. It doesn't need to be precise. You'll just want to fine tune it. And then you could also increase or decrease the gain over here. This is a squelch level. Now, speaking of squelch codes and whatnot, CubicSDR doesn't have a way to set things like DTCSS or DCS codes. So if there's like a ham repeater or whatnot using squelch, you're probably not going to be able to hear them. And then to stop it from doing, this actually active recording, you just hit remove active and now it goes away. Or you could hit record, which you would need to go into recording first to set your recording path, set your squelch level. Maybe you have a time limit on the captures you want to do. And this is in case that you're listening to something of note, or if you have a frequency that you always want to monitor. Perhaps it's the tactical channel for your cops, or perhaps it's the dispatch, or whatever it is, right? It depends on your tasking. So, harkening back to my last video, the deep dive on information operations and signals intelligence, it depends on your overall decision or overall research target, which will inform you for your priority intelligence requirements, which are things that you must know. Like, hey, is there any increase or decrease in the amount of dispatches to the police? Maybe that's pertinent to you because there might be civil unrest or there might be more protests. And if you hear a bunch more, well, maybe that's confirming that something's going kinetic. And maybe if you're not hearing any traffic anymore, that could also be bad because it's like, well, why am I not hearing anything from dispatch? Now, time of day and whatnot depends. I'm out in the sticks here in eastern Pennsylvania between Northampton and Lehigh counties. I'm pretty much right dead center on the county line. So depending on wherever I'm at in my property, I'm on one side of the line or the other. That doesn't really matter. What does matter, though, is that you need to understand your information environment, which is why in that video I talked about at length doing this a lot. Maybe just having the SDR running on the back end, then you have a couple different channels in your recents that you just run through, right? So it could be GMRS repeaters if you want to listen to what folks on ham are chewing the rag about, police dispatch, LE dispatch, search and rescue, if there's any organizations like that. Even federal might have something. Now, if it's on P25, if it's a trunk-based system or something like that, you're going to need to use a different SDR. Again, CubicSDR is just very basic for your analog, unencrypted narrowband FM comms, but because it's so simple, theoretically, it should be easy enough for you to actually get started with. And in addition to getting started with, this is a good way to do kind of a check on learning as far as emissions control, where if you're in the area of somebody, and actually let me change my center frequency over to 136. And then you can see there's a little bit of VHF traffic. You might see these little hot spots. This is probably like text messaging sensor data that's being sent around, but I'm actually going to key up on low power, a radio, and I have my RTL-SDR on a tripod with a really long USB extension cord a couple meters away from me across the office. And now look at that. So you see that very, very high energy and it's coming way above the noise floor. So it knocked everything else down around it. And then you see, just in general, you have a ton of RF radiation. This is happening all the time around you and you can see various blips. So you might end up finding yourself playing whack-a-mole, clicking around to try to listen to something. So we'll try to listen to this guy over here. And yeah, nothing really. So it could just be that it's too distant from you. Now, let's say you didn't want to listen to the Weather Channel or you didn't want to key up on your own radio to learn how to use an SDR. You actually want to get some reps in. So, like I talked about also in that information operations SIG deep dive, you could go to something like this, radioreference.com. This is the homepage for it. You would go to databases and click RR database. And then go to browse all data here on the left-hand side, and then pick whatever state you're in. So I'm in Pennsylvania, Lehigh County, thank you. And then there's various different organizations. Now, not all of these will appear, attractions, businesses, GMRS, media, and whatnot. But you can see I have a ton of frequencies available. It'll even tell you, the tone codes that they use just in case, so you could try to listen to them. And let's see, county police, dispatch, so 158-835. then hit enter again, and you can just paste it in directly. You don't have to write megahertz. And then now I'm tuned over here. So dispatch is a little bit further for me, but you could see some peak. So let's try to click over here, see if we hear anything. And really nothing of note, so we'll go over here. And that's about it. Hey, babe. All right, folks, my apologies. Sorry for the jump cut. I had a phone call come in from my girlfriend, and that means that my little experimentation is coming to an end here. So just to close out the video, um, as you can see, this is not hard at all to learn. And I'm not saying that you must use CubicSDR. CubicSDR has a lot of issues. You know, it's missing built-in decoders. It's missing built-in ways to like set privacy codes and whatnot for narrowband FM comms. But it's the easiest one to get started with, in my opinion. And as you can see, it definitely works. Hopefully, some of those audio recordings actually came in pretty good for you, so that you could be like, okay, yeah, he was actually able to get a station. And recap, if you're on Windows, make sure you use Zadig to get the WinUSB compatible drivers logged in. Make sure you're using the right antennas, and make sure you're away from any source of RF radiation if you could help it. Even if you're in a dense EME, you know, like in a city, in a suburb, in an exurb, or something like that, try to position your antenna in the RTL-SDR using like a USB-A extender or USB-C extender, depending on how you're connecting up into your computer of choice, to move it near a window or whatnot, because you can get interference sources, especially if you're collecting a lot. And I'd also encourage you to look at other SDR hardware that'll give you even more bandwidth, so you could see more things. Right? This is a very human in the loop sort of operation. The next video, I'm actually going to show you how you could automate a lot of this. Now, that's more for ELINT, electronic intelligence, or just for basic RF site surveys, which could be a form of COMINT if you're trying to actually decode those, but it'll be a multi-step series because I'm going to show you how to first capture FFT files. We'll do some basic visualization, use some Python libraries to process the CSV data that RTL Power gives you, which is a command line interface. I'll just need to do some setup around it, probably get a fresh version of Dragon OS onto one of my Raspberry Pis, and then secure shell or telnet into it. Obviously, tell you how to do that, install the libraries and whatnot to be able to capture the data, or maybe even run Windows subsystem for Linux or a Docker container or whatnot. And then we'll just continue along that theme. So if you have any feedback specifically that you want to see, some things I want to get into are ADS-B decoding, AIS decoding, visualization using Matplotlib or Xarray, perhaps some Apache superset, how to start storing and processing this data in such a way that you could store it, cheaply, either on your own local machine or on a cloud-based service like AWS S3 on the Amazon Web Services Cloud. Get into some statistical anomaly-based detection using Z-scoring, and then eventually get into machine learning, maybe some AI agent build-outs. It all really depends on what all of you folks want to see. Without your feedback and without your support, really, for this little crazy side project of mine, really couldn't do too much. And you see the noise floor change. That means we had a high source of transmission around here. Probably one of these guys. But RTL power is better in certain ways than this, just because this is very, very intensive having to click around. And then when you see, a very high noise floor, like on the spectrogram where almost everything is like yellow and orange and you still can't hear it, that's because of, inherent limitations with CubicSDR, which is why a lot of people don't prefer to use it. They usually go with SDR sharp or SDR++. I just wanted to show you what was possible with like the most bare bones, quote unquote, out of date one. So that's all I had for you folks. Again, this stuff is pretty simple, just from basics, and we'll keep getting more and more advanced and hopefully more and more useful. But if nothing else, I hope that you will use this to go, oh, let's try to listen to this guy. Nothing there. But anyway, I hope that this will inspire you to actually go ahead and get started. Because if I'm an idiot, if I could do this stuff, you can too. So I'll see you over at the Dirty Cluttered Tabletop to close this out. All right, folks, thank you so much for taking the time to learn about CubicSDR and just basic SDR software utilities and how to actually get started with them. And as you can see, it's very easy to get started with. And depending on your guys' feedback, I'm more than happy to show you other SDR software and even show you SDR software running on Linux. But pretty much all of the GUI, graphical user interface based SDR softwares act the same. Some of them have more features, more capabilities than others, like SDR Sharp, SDR SDR Angel, things like that. But roadmap wise, I already talked about it a little bit in the recorded session of the video. So go back a couple minutes from here. But the next video I'm going to do on RTL Power, which is a command line utility to actually use these RTL-SDRs. And that's more for your electronics intelligence use cases to do broadband scans really, really quickly. And then we'll do some basic visualization, and then we'll continue to build on that topic, showing you how to process and exploit the data. And process and exploitation, if you remember, is phase 3 of the intelligence cycle. So you could actually start turning raw data into information that's pertinent to you for whatever decisions you want to make, actions you want to take, or just research targets that you have. We'll get into machine learning, statistical based anomaly detection, LLM AI agents, and a couple other topics. And then I might bounce around from time to time. I already threatened, and I intend to make good on the promise to do a couple videos on the Silvus, maybe do some videos on Gotenna, and then I'm also planning a very, very deep dive into LoRa and Meshtastic and ATAC as well, and then that'll branch into other ATAC concepts. So if any of that is useful to you, please consider liking the video, subscribing to the channel, dropping a comment down below, telling me what you want to see, any feedback or whatnot, especially if I got something wrong, because I don't know everything. I'm not a professional, but you should still try this at home. And to close out, shit's crazy in the world, man. If you got family, you got friends, make sure you spend time with them. It's easy to get lost in the sauce with this sort of stuff and, preparing and, doing an intel operation out of your mom's basement. But, don't forget to enjoy real life. Eat more steaks, lift more weights, stay safe out there, and I'll see you on the next one. Mount Lethe Hellfire.